Welcome to another exercise for the workbook Statistics, this time focusing on the topic of combinatorics. Our task here: at the campus of university, 12 professors teach. 7 of them are female and 5 are male. And we have team meetings are realized at a round table. How many seating combinations are possible by free choice of seatings? Part B: in how far is the result from part A changed if no round table exists and differences are only considered in regard to the people's gender? Finally, we have part C: how many possibilities exist to form a fair team with 3 members? So meaning everyone can only be chosen once. Well, let's consider this part by part. If we start with part A, we have a round circle, so we're talking about permutations, but due to the fact that it's a circle and not a straight line, we're actually going to use not the formula of n factorial, but n minus 1 factorial. Well, here we have 12 people, so 12 minus 1 is 11. 11 factorial is roughly 40 million permutations. So there's roughly 40 million seating orders. That was part A. Part B is slightly different because, well, first off, we do not have the round table anymore. That more or less just evens out the comment from before. And now we're focusing only on the gender, so only on male, female. So it's more like male, male, female, female, male, female, and so forth as a pattern. If we have something like this, we call this permutation with repetitions. And the formula we're going to use for this is n factorial, so that's the whole 12, divided by k1 factorial, so how many females we have, factorial, times k2 factorial, how many males we have. So in our example, 12 factorial divided by 5 factorial and 7 factorial. So in this case, we only have 792 possible permutations or seating orders. Finally, well, we want to consider groups of 3. So in other words, we have k by n subgroups. We're talking about a situation without replacement, meaning everyone can be chosen only once. Else it wouldn't make sense talking about a team of 3 if the same person would be chosen 3 times. So without replacement, out of the n, out of the 12, we're choosing 3. So we have n over k, n being the 12, k being the 3, the groups of 3. So we insert 12 over 3, giving us 220 possible subgroups with 3 members each. Well, that's already everything there is to this unit. So I hope you enjoyed it. I'll say goodbye and see you for the next time.